Hello students, welcome once again to Dr. Sourav sir's classes. We are going to begin with the same part of group theory. We were continuing with group theory, and this is the theory part going on with a lot of with a little mathematical example, what I mean to say. So in today's theory part, we are going to talk about some important points on the order of elements, how the order of the elements are going. Okay, we are going to talk on that. Next we are going to talk on subgroups. What are subgroups? Different types of, under the group, what conditions okay, what conditions will make a subgroup. Okay, what conditions is going to make a subgroup. Then we are going to learn points on equivalence relation. Okay, on the groups we are going to see how equivalence relation happens. Then some remarks will be there, some important points, that means, and some important results on subgroups will be explained to you. Okay, so today's topic, we are going to do 1, 2, 3, 4 and 5 points. Okay, moving on to the first thing. So let's go ahead and read the first one. The first one says that OA is equal to O of A inverse for all A belonging to G. What is OA? It is the order of A. Order of A. OA is called order of A. Order of A. So what does it say? The order of A, the order of an element A is equal to its order of its inverse. Equal to the order of its inverse. Isn't it? Just hold on. Okay. So the order of this element is equal to the order of its inverse. So it's given as OA is equal to OA inverse. Alright. OA is equal to OA inverse. Alright. Okay. Moving on to the next part. It says, if G is a finite group, then order of any element of G divides the order of G. So if G is a finite group, second point is, say G is finite, okay, then order of any element of G, you see in the previous video we spoke about order of element, right? Order of an element, I showed you like how A is equal to A inverse, and that means A square, that implies A square is equal to E. So the order of the element is 2. Okay, that's how you find the order of the element. So it says in the second point is that the second point is saying the order, if G is a finite group, finite means not infinity, not extending to infinity, but the group is finite. Okay, it has bound. Alright, so if G is a finite group, then the order of any element of G divides the order of G. So the order of any divides the order of G, dividing by order of any element of G. Okay, any element. Let's move on to our third point. For any two elements A comma X belonging to G, then order of A is equals to order of X inverse A X. So it's given this way, the third point. Order of A is equal to order of X inverse A X. Okay, if for two elements A comma X belonging to G. Okay, if A comma X is belonging to G, then this will happen. Then this top condition is bound to happen. Okay, moving on to our fifth point over here. The fifth point says for any element A that belongs to G, order of A is finite, then for any integer m, a to the power m is equal to e. for that implies order of a by m. Okay, so look, a to the power m will be equals to e for any integer m. Okay, for any integer m, what happens, but the element has to belong to G. The order of a will be finite, then for any integer m this condition will be happening. Okay, alright, moving on to our next part. It says for any element a comma g, order of ab is equal to order of ba. Order of ab is equal to order of ba. That is what given. That is what is given. Actually, it's written. It's gone a little small. I don't know why it became like that. It should not have become like that. Anyways, not a problem. I'm reading it out for you so that you understand. The next 7 point is saying that order of a to the power k is equal to order of a. What is that? Okay, the bracket missing. Order of a comma k. Alright, this is what is written for all k belonging to, where k is an integer. Okay, for all k belonging to n, no, k belongs to n, for only k belonging to n. Alright, so this part is also done. This seventh part is like an equation. Okay, you might want to note this down, this one here. Alright, moving on to the eighth one. It says if the order of a is equal to n, if the order of any element a is equal to n, then a positive integer k or n, then k for n, then order of a will be equals to n divided by, order of a to the power k will be equal to n divided by, order of a to the power k will be equal to n divided by k. So if you have order of a equal to n, then this will happen. Okay, if you have order of a equal to n, then this condition is going to happen. Next point, 9 point, is saying that if a, b, c, if a and b be two elements of finite order of a group G, then order of a and order of b are co-primes. What are co-primes? Prime numbers. Okay, the two prime numbers, any two prime numbers together are called co-primes. Okay, where order of a and order of b are co-primes and ab is equal to ba, then what will happen? Then order of ab is equal to order of a into order of b. So order of ab will be equal to order of a dot order of b. That's what it is written here. Okay, that is if a and b are two elements of finite order of a group G, where order of a and order of b will come out as co-primes. Let's say, if I give you an example, order of a will come out as say 5, right, and order of b will come out as say 3. Okay, so they are co-prime numbers. Okay, then this condition will be satisfied. Moving on to the 10 point, students. Our 10 point is saying that let G be a group and let x, y belong to G. There is a group G and x comma y is belonging to G. If order of a and order of y is finite, order of a and order of y, order of a and order of y, no, order of x. Okay, there is a printing mistake here. It will be order of x. Order of x and order of y is finite. It does not imply that order of x, y is also finite. What they are trying to say is this. Look at this. Okay, well, let me just rub a little bit from on top and let me just show you. Okay, what they are trying to say. They're trying to say is that if order of x is say finite, okay, order of y is also finite, then order of xy may or may not be finite. Understood? So you cannot say anything of the order of xy. Okay, so in these 10 points, students, I would expect you to go through these 10 points Okay, because group theory is a vast subject or a part of modern algebra, I would expect you to go through these points. These points are very, very important. There is a lot of memorizing or a lot of understanding and memorizing work is there. Okay, so please go through these points. We will go ahead and do an example in the next video. That's it for today's video. We will continue this in the next video. So you keep taking as much help as possible from Sourav sir's classes, because all the help that you'll be needing will be provided here at Sourav sir's classes. Thank you for watching, students.